welcome you to this material science class. Today we are going to concentrate over phases. Phase is the state of certain objects at different conditions. If you take water, it is in the solid form and it's called ice below 0 degrees centigrade. It's a solid, it's a phase. The phase is changed when the temperature is transformed from 0 degrees centigrade to some other degree centigrade, more than 0 degrees centigrade. When it's heated more than 0 degrees centigrade, it becomes liquid form. It's called water. And if it is heated further, when it attains the boiling point 100 degrees centigrade, it's evaporated and becomes steam. It is in gaseous state. Steam. So there are the three different phases: ice, solid, water, liquid, and steam, gaseous state. In this way, there are different phases are there. There may be different components. Air contains oxygen, hydrogen, nitrogen, and so on. These are components which cannot be separated easily. When oil and water are mixed together, oil floats over water. Therefore, the mixture has got two phases. Water is one phase and oil is another phase. They cannot be mixed together. They can be separated easily. So, whenever a particular mixture or a combination is considered, there may be different phases, there may be different components, and there may be different degrees of freedom. There may be variation in density, variation in pressure, variation in temperature, variation in viscosity, and so on. So Mr. Gibbs has given one rule, that's called Gibbs phase rule. P plus F is equal to C plus 2. P is the number of phases, F is degrees of freedom, and C is number of components. 2 indicates variation of pressure and temperature in the particular system. Therefore, whenever C varies, the phase may vary or F may vary. And whenever in a particular system, a single metal, for example iron, its phase may be varied due to variation of atomic structure. That is, at different temperatures, it attains different temperature levels. Normally in room temperature it is BCC, body centered cubic structure. When it is heated more than 910 degrees centigrade, it becomes face centered cubic structure. So according to different temperature levels, the variation of atomic structure may be changed. These variations, they are called as allotropic forms of iron. The various allotropic forms of iron: alpha iron, beta iron, gamma iron, and delta iron. At different temperature conditions, at 763 degrees, 910 degrees, 1110 degrees centigrade and 1539 degrees centigrade, it becomes liquid. Some pure melting point of pure iron, 1539 degrees centigrade. So the temperature is varied. The heat energy is used for transforming the structure of atom. By that, the property may be varied. At normal room temperature, the iron may be non-magnetic. When it's heated more than 910 degrees centigrade, it becomes magnetic. And again, at high temperature more than 1110 degrees centigrade, again it loses the magnetic property. Therefore, There are different forms of allotropic forms. They're called different that's called those phases. So iron has different phases at various temperatures because its atomic structure changes. And also in the material contains two components, iron and carbon. There also there may be variation in microstructure. The microstructure, if it is the pure form, it's called ferrite. When it's mixed with carbon, slight with some variations, it's called as carbide, iron carbide. And there are different structures according to the different percentage of carbon, baryte, and sometimes the structure may be in a particular temperature range only, high temperature. It's called the intermediate microstructure, baryte and so on. So when carbon percentage varies, the microstructure may be varied. When temperature varies, the microstructure may also vary. Whenever the iron is heated more than 763 degrees centigrade, 723 degrees centigrade, some austenite begins to form. When it reaches 1130 degrees centigrade, it's called upper critical temperature. Then the austenite becomes fully austenite. And then when it reaches the melting point may vary with variation of carbon percentage. For pure iron, it is 1539 degrees centigrade. When carbon percentage is increased, the temperature becomes low. It is decreasing, and it attains the value 1110 degrees centigrade. For example, that's called 4.3% of carbon. So these variations are represented in a graphical representation. This is called as iron carbon equilibrium diagram. So in the notes, the iron carbon equilibrium diagram is given with various percentage of carbon and various temperature levels. The percentage of carbon is taken along the x-axis, and the temperature variations are taken along y-axis. So this diagram is more important for getting the various characteristics of the steel. Up to 1.7 percentage of carbon, it's called steel. When the carbon percentage is low, below 0.3%, it's called as low carbon steel or mild steel. When the carbon percentage varies from 0.3 to 0.8%, it's called medium carbon steel. When the carbon percentage is increased further, 0.8 to 1.7%, approximately 2%, it is called steel. It's called high carbon steel. So there are main three types of steels are there. When some alloying elements like magnesium, copper, and such vanadium and so on are added in particular percentage to get particular property, it is called as alloy steel. There are more than 2000 types of alloy steels, and they are developing continuously. So in order to get the various properties at different temperatures and different percentage of carbon, iron carbon equilibrium diagram is more helpful for metallurgists, especially in heat treatment processes. Heat treatment processes are the processes in which the metal is heated to high different temperature levels, and it's cooled at different cooling rates in order to get different properties in the particular metal. We already seen that at different temperatures and different percentage of carbon, the microstructure of iron varies. In pure form, it's called ferrite. The microstructure is called ferrite. And whenever some percentage of carbon is included, it becomes cementite. That's called iron carbide. And especially when the in particular percentage of carbon, the the microstructure becomes more bright appearance, like pearl. It's called pearlite. Pearlite. So, and whenever if it's heated and cooled quickly, the microstructure becomes martensite. Whenever it's viewed through microscope, you can see a needle-like structure, some small needle-like structure, martensite. And due to these things, the mechanical properties may vary. In pearlite, which contains 87.5% ferrite and 12.5% cementite, it has got good mechanical properties. Whenever martensite is formed, hardness is obtained. And whenever the metal is heated more than 723 degrees centigrade, austenite begins to form. So austenite is formed fully above 1130 degrees centigrade. So before melting, it's fully austenite. And some intermediate structures like trusite, sorbite, bainite, and so on, they may be formed at different temperature levels, high temperature levels. And at room temperature, it doesn't exist. It's transformed into cementite or ferrite or and so on. So depending upon these things, different characteristics of metal can be obtained. So it will be helpful for metallurgists. And whenever the metal is heated to high level and cooled slowly, it's called annealing process. At different temperatures levels, it may be full annealing or sub-annealing or spheroidizing and so on. There are some divisions in annealing according to temperature levels. Whenever it's heated to high temperature and is cooled in the airflow, it's normalizing. And it's heated to high temperature level above critical temperature and is cooled quickly, martensite is formed. It's hardening process. These are the different various processes. These processes are called heat treatment processes. So for heat treatment processes, for designing heat treatment processes, the iron carbon equilibrium may be helpful. So this iron carbon equilibrium diagram and the phase things are more important in material science. There will be one question in examination. So try to concentrate over this. And whenever the temperature level varies, at different temperature levels, time and different timings, whenever it's kept at the temperature, whenever the metal is kept at a particular temperature for particular timings, the microstructure may be varied. So it's called it's indicated in a particular diagram. It's called as triple T diagram, time temperature transformation diagram. This is also called S curve, which is in the form of S. You can see in the notes. So try to read the notes, and when you got any doubts in these subjects, please try to contact me. Thank you.